Hello Algebra 2 students, this video will be a review over how to solve using the quadratic formula. This is the quadratic formula and it will be given to you on a formula chart. You don't have to have it memorized, but you do need to know how to use it and how to simplify it down to get the answer. So that's what we're going to be talking about today. Before you can use the quadratic formula to be able to solve, your equation must be equal to 0. And if you look at this equation that they gave to us in number 16, it is not equal to 0. We really need to move some things around. So you can move them either direction that you want to. I'm going to move them to the left. So first, I need to subtract this 6x squared so that I can get it to the other side. And I want to combine it with the like term on the other side. So 14x squared is like it. So 14x squared minus 6x squared is 8x squared. And then, I got to bring down my plus 1. That canceled, and I'm left with 7x on this side. Now, I'm still not equal to 0. I got to get the 7x to the other side. So again, I'm going to minus the 7x minus 7x. And there's no x's for it to combine with them on the other side. There's no like terms. And I want it to go in the middle because it is an x term, so it's going to be in order. So I want my x squared term first, my x term next, and my numbers last, and I need it to be equal in 0. So it must be in this format with your a, your x squared term first, and then your x. This is bx plus c. This helps us identify our a, b, and c so that we plug the right numbers into the quadratic formula. So my a is going to be 8, not including the x squared, only the numbers in front of the x squared. My b is going to be negative 7, and my c is going to be 1. So those are the numbers I'm going to plug into the quadratic formula. All right, so now I'm going to be plugging it into this formula right here. X equals negative b. So b I'm going to plug in negative 7 plus or minus square root b again squared minus 4 times a, plug in a, which is 8, times c, which is 1, all over 2a. And my a, when I plug it in again, is 8. All right, so I have plugged in the a, b, and c. Now I'm ready to simplify this mess down, make it look a little bit easier for us. So first I have a negative 7. When I have a negative times a negative, that's going to give me a positive 7. Bring down my plus or minus square root. Then you want to type everything underneath the radical in your calculator. This part is called the discriminant. And this discriminant is helpful so we can see what kind of roots we have. So carefully type it in the calculator. Do not put the square root in yet, okay? We're just wanting the numbers that are underneath the square root. And you should get 17. A common mistake I see students making is not putting this in parentheses. If you don't put that negative 7 in parentheses, it's going to give you the wrong answer. So put the parentheses around it before you square it so you get the right answer. Make sure also that this is a minus sign and not a negative because it's in between things. So those are some things to check if you didn't get 17. All right, for the bottom, for the denominator here, I'm going to multiply 2 times 8, and that gives me 16. So now I have significantly reduced this down. Now, the next thing you want to ask yourself is if you can reduce this radical. So we want to ask ourselves, is there a perfect square that goes into 17? Well, think about your perfect squares. You've got 4, 2 times 2 is 4, 3 times 3 is 9, 4 squared is 16, and now we're above 17. So none of those numbers go into 17. 17 is in fact prime. So in this case, we cannot reduce this radical anymore. So we just check to make sure that nothing else can reduce in our problem. And if nothing else reduces, then that is your answer, and you are done at that point. But you just always want to make sure that there's nothing that can be reduced down, because sometimes you can simplify it a little bit. So that's all you do for the quadratic formula. Before I end this video, though, I want to make sure that you understand what I mean by simplifying the radical. So what I was asking is, when you are asking, is there a perfect square? We talked about the perfect squares were 4, 9, 16, 25, because 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You get what I'm doing here. We could go on forever here. So I'm asking, is there a perfect square, any of these numbers, that goes into what is underneath the radical? Well, in this case, 4 is a perfect square that goes into 20. So I could rewrite this as 4 times 5, because 4 times 5 is 20. So since a perfect square goes into 20, I can reduce this. I know that the square root of 4 is 2. The square root of 5 is not a perfect square, meaning it's going to get a really long decimal. So we're going to leave that inside the radical because we can't simplify that one down any farther. We could round it to a decimal, but that's not what we're looking for. We're looking for a reduced, simplified answer, just like when we used to reduce fractions, what you did earlier. So that's what you would do. And make sure it could be the square root of 4, I should add on, is plus or minus 2. So you want to make sure you do plus or minus 2 for your final answer. So that is how you would reduce your radicals if you can.